In this video, we're going to look at operator precedence. It's something you'll have learnt about in basic maths class, and we're going to see how it applies to expressions in Python. Before I start though, I'm going to delete lines 16 through 21 in our program. I added those just to show you what the for loop was doing, but I don't want to leave it as an example of how you should code. And in fact, I'll take this opportunity to delete the for loop as well. Alright, so our examples so far have been very simple expressions, but they can be much more complicated. So consider the following line as I type it and see if you can work out what will be printed before you run the program. So I'm going to type on line 13 print, and in parentheses I'm going to type A plus B divided by 3 minus 4 multiplied by 12. Then we've got our closing parentheses. So if you can figure out what the answer will be, let's actually run the program and see what happens. You can see we've got the answer negative 35.0. Now if you're surprised that the answer is 35.0 rather than 12, maybe you weren't paying attention in school. Don't worry, your computer isn't broken and you can reliably perform arithmetic in Python. But like with all programming languages, you have to understand some basic rules of the arithmetic operators. Operator precedence is a fancy term for the relative importance given to each of the operators. If they were all equally important, we could just read the expression on line 13 from left to right and we would get the result 12. A is 12 plus B, which is 3, gives 15, divided by 3 gives 5, minus 4 leaves 1 times 12 equals 12. However, multiplication and division have higher precedence than addition and subtraction, so those operations will be performed first. Now, many programming languages work in the same way. This isn't just a peculiarity of Python. So B divided by 3 is 1.0, and 4 times 12 is 48, so the expression therefore is evaluated as 12 plus 1.0, take 48, which is minus 35.0. Now, if you want to make your expressions clear and unambiguous, you can use parentheses freely, even when Python doesn't specifically require them. So along those lines, we could revise our example from line 13 and instead type print parentheses A plus, then another set of parentheses, and B divided by 3 in those parentheses, then a minus, then parentheses 4 times 12. Then we've got our two closing right parentheses. I'll just space that out a little bit so it's a little bit easy to read. So if we run this code again, we get the identical answer, minus 35.0 printed twice. So in other words, both these expressions evaluate to the same value. Now, if we had intended the early expression to produce the result 12, we'd write it a different way. We could do print parentheses. We're going to add another 3 parentheses here. So we've got 4 in total to the left-hand side. Then A plus B, closing parentheses, divided by 3, closing parentheses, minus 4, closing parentheses, multiplied by 12. And then we've got our last closing parentheses at the end of the line. And now if we run that, we correctly get the result of 12.0. Or we could revise that because dividing by 3 has higher precedence than subtracting 4, we can actually remove one set of parentheses. So what I could do is change that to print, and we want 3 left parentheses this time. Then it's going to be A plus B, closing parentheses, divided by 3, minus 4, closing right parentheses, multiplied by 12, and the final closing parentheses. And if we run the program again now, we get the same answer, 12.0. Now we could also use variables to hold the intermediate values if we wanted to. So if I come down here to line 18, I could type C equals A plus B, and the next line, D equals C divided by 3, then E equals D minus 4, then we could do a print, in parentheses, E multiplied by 12. So if we run that, we also get the value 12 outputted. So there will be times when it makes sense to break up an expression into smaller parts as we've done here. I think in this example though, the code's harder to read and difficult to work out what's going on. Compare the two previous examples and see which one you think's easier to read. Okay, so I mentioned learning about operator precedence at school. Unfortunately, many schools use acronyms to help you remember the order of evaluation, but the acronyms are ambiguous. So common acronyms are, we've got PEMDAS, and that's parentheses, exponents, multiplication, division, addition, subtraction. We've got BEDMAS, brackets, exponents, division, multiplication, addition, subtraction. BODMAS, brackets, order, division, multiplication, addition, subtraction. And BITMAS, brackets, index, division, multiplication, addition, subtraction. So what's wrong with these acronyms? Well, they all have the same problem of being ambiguous. Students sometimes interpret them as meaning that multiplication has higher precedence than division and addition has higher precedence than subtraction. And that's not the case. Multiplication and division have equal precedence. Addition and subtraction also have equal precedence. In an expression that mixes operations with equal precedence, they're evaluated from left to right. So let's see that working in Python. So multiplication and division have equal precedence, which is higher than addition and subtraction. And addition and subtraction have equal precedence. Because multiplication and division are equal, expressions using those operations are evaluated from left to right. Let's go ahead and on line 23, I'll do a print left to right parentheses to give us a bit of space. Then on line 25, I'm going to type print, parentheses, and within the parentheses, I'm going to type A divided by, then another set of parentheses, B multiplied by A, closing parentheses, then divided by B, closing parentheses. And if I run this program, we get the result 0.1111111111, and that's 12 times 3 is 36, and 12 divided by 36 is 1/3, divided by 3 is 1/9. If you were taught using those acronyms, make sure you're interpreting them correctly. Alright, so in the next video, we're going to look at the string data type in more detail. See you in the next video.